Okay, what's going on? I believe it's recording right now. This is a problem that I literally was doing last week. It was in the Leak Code contest, and it looked like a pretty good problem to practice. So now I'm going to try to actually solve it. This will be my first time actually solving this answer and getting the correct result. So the first thing I'm going to do really is, I remember I found this out last time, which was if m times k is larger than the length of your array, you're going to return -1 because there's no way. Because to make 3 bouquets from 2 adjacent bouquets without overlap, you could use these 2 bouquets, you could use these 2 bouquets, but you don't have 2 bouquets. You need 2 more. You need 1 more bouquet to be able to make 3 bouquets. Sorry, you need 1 more flower, not 1 more bouquet. You need 1 more flower to be able to make 3 bouquets. So what I'm going to do is just do that. So if, well, first I'm going to do this. If bloom day, and then if m times k is basically greater than n, return -1. Okay, so basic edge case taken care of. Now I'm going to do is, so the thing that I didn't realize when I first saw this problem is that this is really a binary search problem, because you have a so you have a what's it called, you have, I don't know why I just lost my train of thought, but like you have an upper and a lower bound. So like the lower bound is 1 here and upper bound is 10 here. So okay, if I were to try to do that, I would do upper, since we're going to probably do a binary search, we'll just do left, right. So we'll take the min of bloom day, and we'll take the max of bloom day. Okay, so get my left and my right, and I'm going to do while left. So I'm gonna do my regular template for a binary search. It may not work in this problem. If so, we're gonna have to change it up. So we'll do mid left plus right and divide it by 1, or shift over the bits by 1, which is the same thing as dividing by 2, with floor division. So then we do that, we get the mid. Okay, so what's the point of getting the mid? So the mid, like for instance, like if we do 1 and 10, right? It'd be 1 and 10. You add those together, you get 5, and you're like, okay, well 5 is going to be so right now I'm assuming that my answer is 5. And when I say I'm assuming that my answer is 5, I'm assuming that it's going to take me 5 days. We already know the answer is going to be 3 days, so we're going to have to whittle this down. So the first thing that we're going to do is keep track of a count and some type of sum. So the count is going to be, well, let's specify what we're doing here. So count will be, let's see, num adjacent. Let's say we keep track of the number adjacent, and let's say we keep track of, oops, let's say we keep track of num of the adjacent, and also let's say we're keeping track of num of m. And we'll say there's 0 at the beginning. So so if we're going through this while loop, what we might do is we might want to go through for flower, or for day in bloom day. Okay, maybe that. So for day in bloom day, we want to basically see if it is satisfied. So like if day is less than mid, that means that, let's say it's 5. So right now we're saying we believe that our answer is 5, that we can bloom these flowers in 5 days. So we find out 1, we're like, okay, we can definitely bloom this 1 flower, but we have to first off increment the num of adjacent, num of adjacent plus or equal to 1. Now what we have to do is we have to check that the number of adjacent is basically equal to k or not, because if num of adjacent equals to k, then if that's the case, then like we only need, maybe we need 2 adjacent, so we find 2 adjacent flowers that fit days that is under the midday or less than the midday. Then we would want to increment the num of m by 1, and we want to start over on adjacent. We want to set it to 0 because we're going to start a new group of new group of flowers that are adjacent. Of course, it's possible that the day is not less than mid. If for some reason it's 10, we want to make sure we set num adjacent to 0 because it just broke any group size of num adjacent. If num adjacent was incrementing, like if we're doing 7, like if it was 7, it was incrementing, right? It would be like num adjacent 2, 3, 4, and then when it gets to 12, it's like, well, let's say mid is 8, so it's like 12 is too large, so it's like I need to start num adjacent back at 0 for when we start this 7. So num adjacent equals 0. Okay. So that's really nice and all. So we'll end up getting the number of m, which would be the number of bouquets that we can make. So then we want to check if so there's a couple of things to realize here, is that if num m is greater than or equal to m, so this means that either we made the correct number of bouquets or we made too many. If we made the correct number of bouquets, that doesn't tell me that mid is my answer, because the reason why is because mid is guessed at 5, right? It's guessed to be 5, but we know that 5 is too large. We can go smaller, so we know we want to shift. We want to go to the left segment. So right now we have 2 segments, right? It's either going to be between 1 and 5, or it's going to be between 6 and 10, or 11, sorry. 6 and 11. I guess 6 and 11. That doesn't make sense. Why 6 and 11? It's more like it's between 1 and 10. So it's between 1 and 10. And we realize we have 5 right now. And we realize, well, we should ignore the 5 to 10. We know the 5 to 10 is not going to be the answer, so it has to be somewhere between 1 and 5. So it has to be in that left segment. So if we want to get the left segment, we want to move the right. So we're going to say right equals to mid minus 1. Else, we would want to move the left to mid plus 1. Okay, so let's think about what's going to happen in my example now that we did this. So we have 1, 10, 3, 10, 2. So left is equal to 1, right is equal to 10, and mid is equal to 5 initially. When we have 5, we end up getting, we end up moving the right, so left is still equal to 1, but the right will be equal to, also another thing to think about is that really I'm doing the binary search on this. So this is what we're actually doing the binary search on, right? Because our left is 1 and our right is 10. We're trying to find, in this range of digits, which one is correct. So we set our right equal to 4, I believe. So then our mid will be 2. Yeah, so it's going to be Okay. Oh, what is this? Alright, so I'm back. So what I realized for this problem is that, so I had a small error, which was I was returning the mid here, but it turns out like returning the mid doesn't work, because in this problem, when you look through the run code, you end up getting 98, you end up getting this 98, 96, 100, right? And 98 is the answer. But the thing is that because it's equal to or greater, it's going to move the right over to the mid -1 if I'm using this template for binary. And by doing that, it's going to go one less. It's going to go 97, and we're never ever going to get to the 2 again. But it's going to keep, because it's going to be lower, it's going to keep moving the left until the left is equal to the right. And we know that the right is 1 less than the correct answer. So it's going to correct for it, because the last thing it will do is it will move the left to the right of basically where the right is at, so it'll move it to 98. So this will correct for any time you have a situation like this. And returning the left is the way to go here. It will always be the answer. Returning mid will not always work, because you could move the right too far, basically, but you will only move it too far by one place, because the mid might be on the number of days that you want as the answer. But when you do this subtract 1, you might go 1 less than what the correct answer is. So by doing this mid, moving the left to the mid +1 as the last thing that you do when left and right are equal, you want to return left. Yeah, so this works. I already submitted this. Yeah, and it's really fast. It's very good. This is a good practice of using binary search. And I mean, why were you able to use a binary search for this? Is recognizing that you have a lower and an upper bound, because you have the number of days that it could take. It could be 1 or it could be 10. The most is it could be 10. You have this one exception when it doesn't work. But yeah, you have a min and you have a max, which is a lower and an upper bound. You use those upper and lower bounds to kind of like keep updating your bounds until you get to the answer that is the lowest answer, the minimum number of days, basically, that will satisfy the constraints and the constraints of the problem, which is you need to make 3 bouquets with k adjacent flowers. So yeah, so that's the answer to the problem. So like, it's a very good practice problem for using binary search. Yeah, so